Hi, 8th grade. Welcome to lesson 2.8, Understand the y-intercept of a line. By the end of the lesson, I want you to be able to say, I can find the y-intercept of a graph and explain what it means. Let's solve and discuss it. 8-year-old Alex is learning to ride a horse. The trainer says that a horse ages 5 years for every 2 human years. The horse is now 50 years old in human years. How can you determine the age of the horse in human years when Alex was born? Okay, so it says that if we have the human years and then we have the horse years, we can set up a table. Horse ages 5 years for every 2 human years. The horse is now 50 years old. I have to find how old the horse is in human years. So I want you guys to find the ratio. What would you multiply by? 5 times what? 10? So that would be 20. So that means right now the horse is 20 years old in human years. Alex is 8 years old today. So Alex was born 8 years ago. So if we take 20 and subtract 8, that means the horse was 12 years old in human years when Alex was born. A veterinarian says that a cat ages 8 years for every 2 human years. If a cat is now 64 years old in cat years, how old is the cat in human years? So again, we'll make a table. Human, cat. The ratio is 8 cat years for every 2 human years. And the cat is now 64. I want you guys to pause the video and figure out how old the cat is in human years. Okay, so hopefully you notice that 8 times 8 is 64. So we're going to multiply the 2 times 8 to get 16. So the cat is 16 human years old. Example number 1. Determine the y-intercept of a relationship. Matilde and her friend are going bowling. She can rent shoes at a bowling alley or use her mother's old bowling shoes. How can she determine how much money she will save if she brings her mother's old bowling shoes? So if she brings her mother's bowling shoes, she's not going to have to pay for the shoes. Here, the bowling prices include the shoe rental. 1 game is 4, 3 games is 8, 5 games is 12, 10 games is 22. So we can graph that on the graph. And we see that it's a straight line, so it's proportional. Remember, you're using the ratio of rise over run. So the slope is 2. That means the cost of each game is $2. Extend the line to show where the line crosses the y-axis. The y-coordinate of the point where the line crosses the y-axis is the y-intercept. This is one of your vocab words. So think about like a football interception. It's where a player stands up tall, grabs the ball while it's being thrown. So you can think of the y-axis as a football player standing tall, and it is intercepting the ball at that point. Okay, so that point is called the y-intercept. So our y-intercept is 2. That tells me the cost of the shoe rental is 2. So that makes sense, because if the prices was 1 game was $4, and we just found out that 1 game equals $4, 1 game equals $2, so we subtract the price of the game, we're left with 2, which means the shoes have to cost $2. If we're playing 3 games and we know each game is $2, that would be like subtracting 6. Again, we get 2. Let's try it. Prices for a different bowling alley are shown in the graph. How much does a bowling alley charge for a shoe rental? So shoe rentals when we're not playing any games. So we're at 0 at the y-axis. And it crosses the y-axis at 0. And it looks like at 3. So the y-intercept is 3, meaning they charge $3 for a shoe rental. In these examples, why does the y-intercept represent the cost to rent the bowling shoes? Because it's the total cost without playing any games. It's the start cost. Example 2, the y-intercept of a proportional relationship. The robotic assembly line manufactures a set number of parts per minute. Use a graph to verify how many parts the assembly line manufactures. Step 1, predict the number of parts. The machine has not made any parts when it's first turned on, so the answer should be 0. So 0, 0, right? If we don't have any time, we're not going to make any parts. Then we plot the points, draw a line to connect the points. The y-intercept is 0. Remember, proportional relationship has two things. It's a straight line, so it has a constant of proportionality, but it also goes through the origin, 0, 0. So the bowling examples were not proportional because they did not start at 0, 0. Example number 3, identify the y-intercept. What is the y-intercept for each linear relationship shown? Well, remember, y-intercept is where you intercept the y-axis. No tricks there. So we look, okay, the first one intercepts at 2. The y-intercept is 2. That's the point 0, 2. The second one, the y-intercept is below the x-axis. It's negative 0, 1. The y-intercept is negative 1. Last but not least, it's a proportional relationship. It goes through 0, 0. It goes through the origin. Try it on your own. Pause the video, and we will press play to go over it. What is the y-intercept of each graph? So again, we're looking at the y-axis, the y-intercept. So this one, the y-intercept is at 0, 2. So the y-intercept is 2. The next one, where it crosses the y-axis, below, the y-intercept is at 0, negative 0.5, meaning our y-intercept is 0.5, negative. Key concept. The y-intercept is the y-coordinate of the point on a graph where the line crosses the y-axis. So the y-axis. When the line crosses through the origin, the y-intercept is 0. So remember, the origin is the point 0, 0. When the line crosses above the origin, it is positive. When the line crosses below the origin, the y-intercept is negative. All right, 8th grade, let's say it. I can find the y-intercept of a graph and explain what it means. Have a super great day.